According to the National Cancer Institute, roughly 2 million people in the United States are diagnosed with cancer each year. Those diagnosed can go through treatments like chemotherapy, radiation, and/or surgery in hopes of curing their cancer. But what if I told you that the key to defeating cancer is a small cell that resides within each of our bodies? Hello, my name is Nolan Letterman, and I'm a senior studying biology at Purdue University with a keen interest in cancer research. Today, I'll be talking to you about stem cell therapy and its impact on cancer. In this presentation, I'll go over two types of stem cell treatments: autologous transplants and allogeneic transplants, as well as some of the promising discoveries made in both transplant fields. Additionally, I'll go over how stem cells can be used to increase recovery times for patients undergoing grueling chemotherapy treatments. Before I begin, it's important to understand what exactly a stem cell is. According to the University of Rochester Medical Center, a stem cell is a cell that can develop into other types of cells. This allows them to have multiple functions within the human body itself. In regards to cancer therapies, a February 2020 article published by Chu and colleagues highlights three main cells that stem cells can transform into: platelets, red blood cells, and white blood cells. We will talk about the importance of these things later on in the presentation. As I mentioned earlier, there are currently two types of stem cell treatments available: autologous transplants and allogeneic transplants. On the left, you will see a visual of the autologous transplant process, and on the right, you'll see a visual of the allogeneic transplant process. The allogeneic transplant process is one that does not require a donor. Rather, stem cells are collected from the cancer patient and frozen. The blood is then returned to the patient with chemotherapy or radiation to follow. After the completion of the treatment, the frozen stem cells are returned to the patient by reinfusion. Conversely, an allogeneic transplant is a procedure that does require a donor. Stem cells are collected from the donor while the patient undergoes chemotherapy. After the completion of the chemotherapy, the patient receives the donor stem cells. As previously highlighted, there have been major discoveries made in both stem cell transplant areas that can have major impacts on cancer and remission. The first discovery comes from a January 2020 article by Chu and Associates in the Blood Medical Journal. This article goes into extensive detail about syndican-2, a protein that is often associated with early stem cells. In these experiments, Chu and his research team found that when stem cells were marked with syndican-2 and reinfused into the bloodstream of mice following radiation treatments, that the blood cells of the mice repopulated at a very high rate. So as you see here with the graphs, the red marks that the stem cells that are marked with syndican-2, and the blue represents the stem cells that don't have any syndican-2. The red stem cells have an increased recovery rate in total cells, and the blue ones just have a constant flat rate around 0. So the second discovery comes from a 2021 article published in the BMC by Shokafar and their associates. The research was done to find a new potential target for allogeneic transplants. The research found natural killer cells, a type of white blood cell that has an increased affinity to attack various types of cancer cells. The article goes into detail about the development of the NK cells in the bone marrow, as shown here on the slide, in the various pathways that it goes through to target these various cancer cells. The NK cells can be harvested from various bone marrow donors, hence allogeneic transplants. It can hopefully help combat cancer effectively in the future. As I have mentioned, stem cells can lead to increased recovery times in patients undergoing chemotherapy. In a November 2021 article published by Chu and colleagues in the Natural Communications Journal, Chu and his colleagues outlined the research on neuropilin-1, a mechanism that regulates blood vessels within the bone marrow after sustaining an injury like chemotherapy or radiation transplants. In their experiment, Chu and his fellow researchers used rats and treated them with radiation. From here, the researchers would either activate or inhibit neuropilin-1 in the cells before reinfusion. When neuropilin-1 was inhibited, cell growth was promoted, as shown in the graphs in Figure A. While this has not been tested in humans, by applying these findings theoretically, it should reduce the recovery time in chemotherapy patients from 3 to 4 weeks to 1 to 2 weeks, which is pretty significant. In conclusion, I hope that this presentation has introduced you to the world of stem cells and how pivotal they are in creating and improving upon cancer therapies. Hopefully one day stem cell therapies will be more widely utilized and available to cancer patients. Thank you for your time.
Good job. Can we applaud?
Show your notes.
There you go.